Okay, good day one and all. Welcome to my YouTube channel. Today we are going to solve an example from logarithm. Example that we use a logarithm process. A logarithm. So logarithm, when we say logarithm, we are trying to express the simplicity of the multiplication numbers or division numbers. We express these numbers into a logarithm form by taking the addition and subtraction method. So it helps us to simplify a larger computation of a number by using plus and minus. So now we are going to take this example which says a cube root on open bracket 0.0256 times 500 over 325.7, that is 325.7 close bracket root 2, close bracket root 2. So all these steps. Now how can we solve this? First, we need to break it down into three sections. So the section ones, we bring out the numbers. Then after we bring out the numbers, we convert these numbers into a standard form. So from this standard form, we can be able to express the logarithm function. So now let's start. The first number is 0.0256. So it's 0.0256. How can we do 0.0256? So we convert 0.0256 into standard form. So from now, you see now, this number is lesser than 1. Since this number is lesser than 1, we start our count. We'll move the decimal point. We'll move it to the right hand side. So we start the count 1, 2, 1, 2. So now we see that 2 is greater than 1. So in this case now, since the 2 is greater than 1, we stop. That will take it 2.56 times 10 raised to power minus 2. 2.56 times 10 raised to power minus 2. See? 2.56 times 10 raised to power minus 2. So now we have converted it into standard form. So from this standard form now, we can be able to express the logarithm function. So now how can we do the logarithm function? So you can see it. Now it has two numbers. We have 2.56 times 10 raised to power minus 2. The first thing we need to know, there are things we need to know, and we need to take it serious. So the 2.56 is known to be the mantissa. Why 10 raised to power minus 2? The minus 2 is said to be the character. The said to be the character, that call it characteristics. Said to be the characters. So now, how can we express this in standard form? Then you take the log. What is the log of 2.56? So the log of 2.56, we take it. And what is the log of 10 raised to power minus 2? So in this case now, one of the principle of logarithm is, one of the first law of logarithm, he said the log of a product of two numbers can be equal to the sum of the log of a different numbers. That is log A. Log open bracket A times B can be expressed as log A plus log B. Can be expressed as log A plus log B. So in this case now, we have 2.56 times 10 raised to power minus 2. So how can we solve it? Then we say log of 2.56 and log of what? 10 raised to power minus 2. Since we are using a common logarithm are logarithm with base 10. So now, common logarithm are logarithm with base 10. How can we get our final result? So getting our final result, we now said that log of 10 raised to power minus 2 can be, right? We can write it as what? Minus 2 in logarithm form. Minus 2. So writing it as minus 2. So you see, we can write, if we want to write it to simplify it, we just write 2 and take the minus, put it at the top. We call it bar. So it will now become, instead of calling it minus 2 in this kind of expression, we call it bar 2. See, bar 2. So now we have bar 2. Then we will now calculate for the logarithm of 2.56. So the logarithm of 2.56 is said to be 0.40824. So it's 0.40824. We now do what? We sum both of them. Since we said we convert products into sum, that is the log of two, the product of two, the log of a product of two numbers. The log of the product of two numbers can be expressed as log A plus log B. So now we sum them together to get this answer. So we get the answer to be what? About 2.40824. So likewise, we do for the 500. The 500, we convert the 500 into a standard form. Converting the 500 into standard form now. So we move, since the 500 is greater than 1, yes, then we now start moving into the left. We'll move the decimal point to the left, 1, 2. So when we have moved the decimal point to the left, we have 5 times 10 raised to power 2. 5 times 10 raised to power 2, our mantissa is said to be the 5. Then our characteristic is said to be 2. So how can we write it now? We do the same process as we do for the first one, which means what is the log 5 and what is the log 10 raised to power 2. So log 10 raised to power 2 is going to be 2, and log 5 from the calculation is said to be 0.69897. 0.69897. Then the next thing we do is we sum them. So summing the 2 plus 0.69897, it will be 2.69897. 2.69897. So here we say we convert, we have any multiplication sign will be represented as plus in logarithm. Any multiplication sign will be represented as plus in logarithm. So now this is plus, then it will become, this is multiplication sign here beside the 500. So the multiplication sign here, now it will be converted as plus in this place. So we have about 2.40824 plus 2.69897. So we sum them together. But let's take note of this. Summing them together does not mean that we will match them at once. No. What we're doing is we'll take the number of 0.40824 plus 0.69897. Then we sum them together. Then we take the number of bar 2 plus 2. Bar 2 plus 2 is what? Is 0. Automatically 0. So since it is 0, then after we have summed the 0.4, which is the mantissa number, these are the character numbers. The mantissa number, after we have summed them, we have 1.10721 as our result. So this is the result. This is the result of when we are, if we want to look for the logarithm of 0.0256 times 500, the result will be 1.10721. That's the result. So now for you to further the processing, we divide it by what? We divide it by 325.7. See, divided by 325.7, which means we have to convert this into a standard form again. Converting it into a standard form now. So we want to convert this 325.7 into standard form. We'll move the decimal point to the what? To the left. 1, 2. 1, 2. So moving to the left now, it will be 3.257 times 10 raised to power 2. 3.257 times 10 raised to power 2. So now, since we have 3.257 times 10 raised to power 2, every division function in logarithm will operate as what? Minus in logarithm. It will operate as what? Minus in logarithm. So now, since we have looked for the logarithm function of 325.7, which is 2.51282. So here, for me not to run too fast, you see the mantissa here is 3.257 times 10 raised to power 2, while the characteristic is 2. So now, we take the logarithm of 3.257 and also the logarithm of 10 raised to power 2. Yes, the logarithm of 10 raised to power 2 is 2. Write the 2. Then the logarithm of 3.257, then it will give us 0.51282. Is 0.51282. So this result that we got from this place, that is the 2.51282, will be subtracted from 1.10721. 1.10721. So it will be subtracted from 1.10721. So if you subtract it, you just here now. You see, the processing here is different. We subtract direct without comparing the mantiza value and the character value. We subtract direct. So when we make our subtraction, we have minus 1 point minus 1, which is by 1.40561 by 1.40561. You can see very well here, by 1.40561. This is 5, is not 8. By 1.40561, as you can see very well, by 1.40561 here. Now that's the result. This is the result of 0.0256 times 500 over 325.7. That's the result. So the next case now, we are dealing with a root, a square root, right? Since we are dealing with square roots, we have to square the entire numbers. We square the entire numbers, that is everything inside that bracket. We need to square them. So now 0.0256 times 500 over 325.7 will be squared. So now how can we bring out this expression? To bring out this expression, we look to the logarithm rules. So one of the rules of logarithm is log, that I make characters. I said log a raised to power 2 can also be written as, when we move these 2 to the other side, we move it to the back of the log, will be 2 log a. So 2 log a. Similarly, we can write the entire character like this, that 2 times the entire thing that is inside the bracket. When we compare it to the logarithm form, that is 2 times our results. We got the 2 times by 1.40561, which should be equal to by 2.81122. So again, now everything that is inside the roots, that is the square root, the root of 2, not square. Everything that's inside the root of 2, the root of 2, not square. This is square, the root of 2 rather. That is root 2, and everything that is inside the root of 2, which is root 2, also known as root 2. So now we have cube roots of of everything inside that root 2. So we can also express this in logarithm form. Log cube root a can be expressed as log a raised to power 1 over 3, which is 1 over 3 can also be written as 1 over 3 log a. So here now 1 over 3 log a times the result we get from the previous one, which is times 2 bar 2, 1 over 3 times bar 2.81122. And now in this case we have minus 0.93707. You see now minus 0.93707. Here now our mantiza is never negative. Our mantiza cannot be negative. Our mantiza is always positive. So since our mantiza is always positive, because we try to make the expression of mantiza, we said is from what? Our numbers. Since we are reading from base 10, is 0 to what? Is 0 to base 10, right? That is from 1 to 10. From 1 to what? From 1 to 10, which means 1 to 10. Log 1 is equal to what? Is 0. Log 1 is equal to 0, while log 10 is equal to 1, which means our mantiza is always positive. Our mantiza is always positive, and its vary from 0 to 1. It's vary from 0 to 1. Whenever our mantiza is negative, our mantiza is never negative. So our mantiza vary from 0 to 1. How do I express it? I said we start our number from 1. Our digit number start from 1 to 10. We are dealing with base 10, right? 1 to 10. So log 1 is equal to 0. How do I make that expression? Anything raised to power 1, anything raised to power 0 is what? 1. Anything raised to power 0 is what? Is 1. So log 1 is what? Is 0. Then the other side, log 10 is what? 1. So our mantissa is always positive. So how can we convert this negative mantissa into a positive mantissa? -1 plus 1 is what? -1 plus 1 is also 0. -1 plus 1 is 0. So here we make that character, we make use of that kind of expression to convert this negative mantissa. This is negative mantissa to convert into positive. So it's 0 minus 1 plus 1 minus 0 0.9. They will subtract that mantissa is 0.93707. So here we have our result as about 1.06293. Please, if you do not understand this, try to comment, then I will explain again. So I said our mantissa is always positive. And how do I define that? I said since we are dealing with a common logarithm, which means a logarithm of base 10, so our count start from 1 to 10. 1 to 10. So log of 1 is equals to 0 and log of 10 is equals to 1. So our mantissa is always positive. It varies from 0 to 1. So now here we have minus to be our mantissa. So here we convert it. We convert the mantissa into positive. So when converting the mantissa into positive, we have 0.06293 after we have converted it into positive. Then the next step of what we do next now is that this our result we got here, we will convert it back to antilog. Converting it back to antilog is want to express this in number. We want to get back our result in number. So how can we do this? First, you take the mantissa value, which is 0.06293. You take the mantissa value 0.06293. That's the mantissa value. So when you take the mantissa value, you will now do what? You antilog. I do it with my calculator. You will do the antilog and you have 1.1559. 1.1559. That will be your answer. And now you express that by 1 back into standard form. Expressing that by 1 into standard form, it will be what? 10 times 10 raised to power what? 10 raised to power minus 1. That's that by 1. You express it in standard form because we say this is the mantissa value. So the mantissa value starts from mantissa, while the characteristic will stand for characteristic. So 10 raised to power minus 1. 10 raised to power minus 1. So 10 raised to power minus 1 times 1.1559, it will be 0.11559. Thank you very much. Thank you for watching this my YouTube video, and please, if you find it useful, try to like and subscribe to my YouTube channel.